Hi everyone, this is Yogesh back with another podcast. This time in our guest we have K. Shreenath Bohra. K. Shreenath Bohra right now is working in Boeing's and is at the position of electronic design and analysis engineer. Coincidentally, K. Shreenath is also from the same college from where I am, which is MBM Engineering College. We share a lot of common interest including machine learning, most importantly, electronics, working with robotics, and many more things that I realized when I had a discussion with him. In our discussion, we touched a lot of topics, including environmental crisis, our perception on how we see the environment, how we see the resource usage from we as humans, and what we can do to improve things on that front. But most importantly, we had a great discussion about how silicon chip has impacted the industry right now hugely, and what are the coming advancement in the future, which we are right now sort of looking forward to. We also touched on a very interesting question of do we really need to have, do we really require any technological advancement as at the stage where we are, or is it something which we keep on doing because we have the potential to do, or we just want to do it? So it was really nice talking to all these questions. We touched it from philosophical side, from technical side, and we definitely had a lot of fun and interest in having all those discussions. I hope you like this conversation, and I'm sure there is so much for you to take on. Again, thanks again for taking the request and joining in and having this discussion with me. The very first thing that I would like to understand and would like to ask you is right now you are working at Boeing as an, I
Yes,
guess, electronic design analysis engineer, right?
indeed.
So, from the college time or from the school rather to joining till Boeing, how your journey has been, and what are the pivotal moments that you can describe in your life which led you to where you are right now.
So as of my journey, to be very frank, I started my aspirations around astrophysics. So when I
Okay.
was very at the nascent age, I was dreaming to become an astronomer. And over the due course of time, being an astronomer requires you to understand science at its core fundamentals.
Okay.
So that made me motivate to each and every concept of science altogether. And what was unique about this journey was I was not satisfied with what was written in the text. So I wanted everything to be demonstrated in front of me. Thanks to
Okay.
my parents that they provided me with all the resources to actually see what I am learning in my textbooks. So if you look from perspective of us as builders, the very foundations of electronics are laid there. Because the easiest form of realization of any scientific concept is through electronic media or electronic implementation. If you
Okay.
look at school projects,
Mhm.
the most unique projects or most fascinating projects are ones that involve a motor and a battery that is connected, and anything that moves around fascinates audience that are there at any school exhibition.
Mhm.
So that started our journey altogether. And going forward, yes, we all appeared for JEE and examinations like that. So by that time, I had this sense of maturity that electrical or computer science is the where I am seeking forward my career. That would somehow realize my dream of astrophysics in retrospect. So, with that decision at the back of my mind, I happened to join this college called MBM University. That was Australian General and Wales University. And though it was not my first choice, but then to own it with respect gave me some really good returns over the due course of time. And there, thanks to the liberty of time that we've had, I was able to explore even further depths of electrical and electronics as a domain and computer science as well, because you know how India works. Uh, Computer science is where the whole trend is. So at that very, I would say, adrenaline rush, I was also part of it, and I enjoyed that journey. But yes, around second year, my professor at one of the research interns, he called up and said, Mr. Srinath, in order to excel in your career, there's one thing that I demand from you is that you need to be proficient with the domain that you're pursuing. In your case, is electronics. So at least do something for electronics so that you can justify after these 4 years that I've bring or I've learned something that is worth my time of 4 years here at engineering. So yeah, his point of view really enlightened me as individual, and that made me work on to concepts of core electronics. And yeah, unfortunately, our placements were more feeble thanks to the corona and associated market letdown. But yes,
Yeah,
whenever the market started to rise, that's where I put in all my chips and tried to explore opportunities. And yes, thanks to destiny that what I was manifesting to be in the domain of astrophysics or space or flight, to summarize, that was rewarded in form of Boeing. I was only assuming Boeing to be a aeroplane company, but who knew that it was also dealing with space flight sciences? And here we are, still learning and hoping that the journey even brings in more manifestations that are there.
got it. So it's a kind of dream come true in a different way, but in a way.
Indeed.
So one thing that fascinates me about your journey is you have been working on your own on electronic projects from very start, I guess, from the college part. What really motivated you doing that, and did that really help you in pursuing and getting the opportunities that you have at the moment?
Well, a quite interesting question. You see, we as individuals, I'll again come back to the very software development aspect of it. Unlike most of my friends, I was more into interest of getting the depth of anything. So, wherein everyone believed that, okay, there exists a black box wherein you code in and you get the executed output. What fascinated me as an individual was what happens behind that black box. Why this computer is giving me the same output? What makes it give the output? So that made me explore further layers of it. And thanks to one of the professors in our college, Mr. Alok Singh Gehlot, so wherein I was saw that I lost all my hopes, or rather, I hadn't had perfectly justified my dreams by being into the third preference of my college. He was the one who was there at our back, and somehow that very gap that was there of my inquisitivity and the actual fundamentals that go hand in hand of those systems, he was there to bring in and bridge the very gap. And over the due course of time, yes, while exploring the depth of it, he made us play with the electrons. So that's how I would like to summarize it for you.
That's, I'll say that's very true. Like, if I have to share my experience um, working, or rather working under, Mr. Alok Galot sir, and again, he's my teacher as well. If for others to know, one thing that kind of really one thing that I really liked about them one thing that I really like about him is he is a very encouraging person. If there is something which you are really doing new, or something which can really help you out in your journey, or let's say if you don't know exactly what you want to do, and you are figuring out what are the real possibilities, he is the one who motivates, and he is someone who actively inputs the same energy level as what you are expected to do. So it kind of pushes you as well that you need to do more. Coming back to you, I would like to understand what are your long term goals, how do you see yourself, and Yeah, what are your long term goals? Let's start with this.
If I look from long-term goals, my long-term goals pretty much straight. Though I have seen the world of astrophysics as I wanted to see in one way or the other, but yes, over the due course of time, I want to somehow do something for the country at the end, and
Mm-hmm.
not just country. And if I talk in terms of fundamental level, at least something I can give back to the society. Because you see, at the end of the day, economics, social status, these all are sidelined once you approach that very point, what you were able to give in back. And that's what I'm trying to help. And there are certain fields wherein I believe I can share my insights with society, or rather, I can take in their inputs and represent them as an individual at some platform or the other. You see, I happen to be from the state of Rajasthan. There, that too, I happen to be from Marwad region that falls in Thar Desert. So
Right.
this region has had a prevalent water shortage, and we've been able to survive it and manage it over the due course of, uh, let's say, from when we started to live here as a civilization in the region of Thar Desert. So, what lessons learned we've had? A bit of technology infused into it that would be beneficial in one way or the other for the forthcoming world. You
Mm-hmm.
see, there's this very underlying factor. We have seen rise of AI, we have seen rise of technology, but what goes at the very fundamentals of it is high influx of water that is being flown, that is not reusable, and in near future, let me sound a bit dystopian, but we won't be dealing with markets of shares of a company, rather liters of water, to be very frank.
Mm-hmm.
So I believe we as a community in Rajasthan, how can we make sure that the situation doesn't worsen from what it is today? And at global perspective, what lessons that Rajasthan utilize can be beneficial for global village altogether, because what they are going to see over the due course of 20 years, we've seen that in our past, and we are seeing it currently. And yes, in process of it, what all things that are there available in the global world, and what lessons we as individual can learn from them, I can convey it back to my community. You see, speaking of Ganesh Chaturthi, as the season is right in front of us, this is one thing that I love, or rather that I've learned from Bangalore, where I currently happen to live, is the very connect and sincerity they put into their culture. We also celebrate festivals greatly, but the very importance, the very, I would say, pureness of our rituals that you can see here in southern part of India, and the respect for their individuality. So whenever I come back to my own hometown, these lessons, when I discuss it with my families and and also peers, they're also fascinated. So I believe in that way, through these small steps, and of course the macrocosm of conservation and environment sustainability, I believe I am also empowering myself, and in a way would be able to somehow make people feel themselves empowered. I'm not the one to empower them; they themselves can empower them.
You can pass on the ideas. They can
Indeed,
kind of weigh in on the idea for sure. But yeah, someone has to take the lead, and that's a very noble of you to think that how to resolve the society issues which will be coming in the future, which no one probably is right now thinking. And I guess the environmental concerns are in the coming past years, yeah, even something which government is also trying to take seriously and trying to understand how can they make the changes in the administrative part, or how the resources are utilized, so that we don't really go and shift ourselves there, or we don't shift ourselves sooner there. That's true. But still, I would like to understand and go a bit more deeper into it. I would like to understand, what do you think, what kind of water shortage will we have? Is it that we won't have pure water to utilize, or we won't have water at all? Like, have you seen the Dune movie? Like, because since you are mentioning this part, it really struck me. So in
Yeah.
Dune, there is shortage of water.
Agreed.
There are so they have some fascinating ways of dealing with it, and I'll come to it. But coming to the realistic picture, I would really much like to understand, how do you see the water issue coming in? Is it that we won't have pure water in our with ourselves to utilize, or is it something that we won't have water at all for some XYZ reasons? How do you see it? Um,
Yeah.
and what do you see how technology can help, or like we are engineers, for instance. So I guess
Yeah.
whenever a solution has to come from us, it always comes with a blend of technology. So how do you
Agreed.
think technology will help, apart from awareness for sure, will help to get through those situations?
You see, water as an element would be perennial on this globe, and
Hmm.
that has been perennial. If I want to go back to fundamentals of our geography, 70% of Earth is water,
True.
and out of it, the water that we have access to is now limited to 0.9, 0.8%. Earlier, it was 1 or 2%. Now it is 0.9, 0.8. To be very frank, with all the data that we are able to analyze at the moment. So the concern primarily is not of water shortage, is of water accessibility.
Okay.
How much water we have accessible. And speaking of technology, why technology is a dual-edged sword is the very fact is if we utilize it in limited amounts. If I want to put it very in one word, we want to be collaborative with technology. We don't want to co-author technology as such. What I mean to say here is technology cannot be an alternative to the existing crisis. It can
Mhm.
only catalyze or poison the process. To give you an example, you've seen the weather of this year, 2023. What's the difference that you've found over the seasons that we have experienced in 2023 and 22? Any input?
I guess the the normal trends don't apply. Like when you are supposing that there will be rain, it is not raining. It's rather
Indeed.
also a bit sooner or later. Like right now, it is raining here. Apart from it, same goes for other patterns, like when the winters is coming, when the summers is coming. It's a kind of shifting pattern. You don't get to see the same behavior of weather rotation what was there in 2022 as compared to 2023. That is one thing that I can see. Other aspects which I feel are happening right now is the extremes are going extreme. Like and this is not again very consistent. There are some areas wherein there used to be an extreme type of climate, but now there is not that really, or it is kind of fluctuating. But there are certain areas wherein the in summers the air temperature is really very high, or they reached a new level. Same goes for the air temperature going very low. So these are also few of the variations that are visible. So yeah, that's what I can see right now.
Well, rightly said, and quite perfectly summarize what I want to convey from it. You see this change that we are seeing, shift of weather, I would say weather calendar altogether,
Mhm.
and changing of nodes and antinodes, as we like to call it in physics, and in more geographical sense, the leeward centers and windward centers. Why it had happened? The other day, if you've read it, I believe Saudi Arabia and Mediterranean countries altogether, they've started experimenting with concept of artificial rain.
Right.
So what they do is with technological enhancements, they increase the colloidal capacity of clouds and make them rain instantaneously. The problem with it is how nature gifted us the weather season was through the phenomenon of easterly and westerly winds. Of how these winds worked were they started all the way from Pacific, all the heading till Indian Ocean, and over the due course of their sweep, they carried the humidity and would then disperse it out into the regions where it was supposed to disperse. But then the very density suddenly has a vacuum in the region of Mediterranean and Middle East because they are artificially puncturing the very tire of movement. So
Mm-hmm.
what happens is now that would portion becomes the region of high pressure, and over the due course of time, a lower pressure. So changed its direction from where it initially was happening. As a change of this direction, the time of normalization increases, which in turn increases the time of arrival here in India and in other countries as well. And this small change is creating magnitudes of effects in our weather calendar. As we like to call it in the domain of astrophysics, the butterfly effect. So,
Mm-hmm.
wherein a single butterfly was able to change the weather patterns over the North America. So, this butterfly is way much bigger in size and is technically capable. And unfortunately, it's that hidden knife that we are puncturing on ourselves. And speaking of, I would say extremities, two factors come in picture. The very technology that we are utilizing is the biggest culprit of non-renewable energy consumption.
Mm-hmm.
And you see, though it's quite hypocritical of me to speak of this as a topic, because I happen to be from the domain of aerospace and electronics, which are the most polluting factors of human innovation. But still, to give it more sense, the very magnanimous, I would say, intent at which we are polluting, it gives us a bit of discretion on to our decisions. And this is what is giving me a motivation to give it back to society in form of the importance of environment. To give it more sense, the number of technological enhancement that we have seen over the past 10 years, they are equivalent to the enhancement that we have had seen in the span of World War II all the way till 2005. And this span has been exponentially increasing over the period of time. And now it is at that very extent that we as individuals have to limit our demand. Because if we won't limit our demands or aspirations from technology, going forward, Mother Earth or nature in return won't be able to compensate to our requirements.
Mm-hmm.
To give it more sense in Hindi, we are literally spreading our legs beyond the chadar of, I would say, nature reclamation.
Okay.
And after that point, we will be in one way or the other, the dystopian future of Dune. So that's how I would like to provide a depth to the context. And there's this wonderful book that I will share with you over the due course of this discussion. I'm not able to recall it at the moment. So that's one book that would give you a context how these things come in picture and how we won't be able to tackle them over the due course of reality. So that's how I would like to put it.
Fascinating thought. So I kind of have two questions right now with
Yeah,
the perspective that you mentioned. First question about what Saudi Arabia is doing. What you mentioned is
yeah,
very much right, but the
yeah.
question is what, as per you, what they are doing is right or wrong? Because looking at from their shoes, they are able to get some rain, which is which is hard for them to get. They're able to, with the help of technology and understanding of all the scientific phenomena, they're able to get their needs met. Um, that's question number one. How do you see it as how this is going on? Second question is, second question is, do you think technology is something, like you mentioned, it's a double-edged sword. Technology is something which is kind of pushing us back in terms of longevity of the uh, human race or the world race in general, because we are consuming resources a lot. Is it the technology who is not right here, or is it that it's not the technology in general, but technology, like you mentioned, is a catalyst, and something else is there which is really getting those impacts in them? If that is a scenario, that is, what do you see? What are the real culprits here, and or what are we supposed to do as an individual and as a society to ensure that we do things in a right manner, in a controlled manner, so that we don't sustain any damage in our future, and so do we ensure that our coming generations won't have issues as well with what we are how we are using the resources right now, etc., etc. So starting with the first question about the Saudi Arabia part, and then the second question.
Yeah. I would like to not personify Saudi Arabia as a country. We all are one in one
Sounds
way or the other. Yeah,
right, that's true.
one way or the other
But
culprits
the
of
thing is,
yeah,
developing countries are right
yeah,
now generating electricity via coal, and coal is, again, that is one of the medium via which the air is getting polluted because of the residual. But
yeah,
but yeah, so please go ahead. I understand what you want to
yeah.
say.
You see, concept of countries is there because of people. If people
Right.
are living in a country, then the question of need and want happens. So, what is required to be changed is our mindset. How
Mm-hmm.
much of resources we need, how much of resources is wanted, how much of it is actually required for our survival and to live a peaceful life, and how much of it is our, I would say, desires that is not necessary for us to glide our way onto life, but these are the luxuries that we are utilizing. In context of our case study that we took of Saudi Arabia, you see there, as a species, if we are not able to cultivate anything, if we are not able to survive anything, we are getting some natural resources from that country. So that should be the main focus. Okay, at the moment, it is providing us requirements and we are satisfying it. Okay, good. But then their very luxury of creating that region as a future colony in order to generate cash is what is the problem.
Mm-hmm.
You see, you've had good amount of capital that is being generated through extraction of oil. So let it be. You are able to survive, or rather, you are able to live a very good life. The citizens of Arabic countries, they are enjoying their life. So, is there anything that is required beyond that? And not just Arabs. If I want to give it more context in terms of my own country, India, uh, you see, we are at the very criticality of energy consumption.
Mm-hmm.
However, in India, the scenario is totally different. To people like us, we don't even bother turning the geyser on and leave it on for, let's say, 10 hours, and we don't even look onto it and we just forget it and turn it off.
Mm-hmm.
But then there are individuals in India who are waiting for 10 hours just to get a bulb illuminated into their home so that they can study in night, and they're working their whole day grinding stone, generating heat so that the water that they have in frozen form can be melted and just be like potable for enough to drink. So India, again, we are sharing both the perspectives, wherein need and want both are being highly catalyzed in their requirements. So what we need as individuals is we can bring in value from the problems that are faced at the very minority of the resources where they don't have it, and we can enable, I would say, a thought of, I wouldn't say conservation because that would sound a bit preachy, but at least awareness of what they are utilizing. Um, what our parents used to say, okay, turn the lights off. For them, the context was, okay, if the light is on, we'll get a bit more bill. But that philosophy, now when we are earning, and that too a good amount, we counter it by saying, okay, we'll pay it off. But what we don't know is we have not inherited these resources from our ancestors. Rather, we are crediting it from our younger generations. So the very moment we are able to bring in thought process at our individual level, I think the issue of energy conservation, or I would say resource mm, malfunction, to be very frank, would be sorted at individual level and country level altogether, and global level as well. Again, microcosm creates macrocosm. And on a concluding note, what is required is the individuals who cater this very demand of generating awareness. Can we bring in products? Can we bring in preneurs that can create value in this domain? That's where demand can be addressed. Why we are eating, like to give it context, why we are eating Parle-G with a chai is because we were advertised that, okay, chai is looking good with Parle-G. We have been advertised it since our childhood, and who is advertising it is this company called Parle. So if we are able to bring in preneurs that have solutions that enable us to, in one way or the other, be aware of environment. So that's how, if we bring in retrospect, technology as a collaborator can help us solve our own problems. So yes, it would be more or less like a rusting process. You see how rust works by depleting the topmost layer of a metal. It protects it up until it is there. So let's rust it forward and mature it, season it, as we like to call it.
Right. Got it. So, got your perspective. One thing that I'll definitely agree upon is that we should be mindful of using our the resources and using it in right way. That is that is an wise way to do it. But on the other hand, I can't stop thinking of you know cases on context. The cases on context to context basis is um, like as an individual, as in society, as in country, as in world as well. When you think like ultimately what we are doing right now is we are trying to understand how can we prosper, how can human society in general prosper, how can Indians in general prosper, how can Rajasthanis in general prosper. That is the kind of um, push that we have. How can we make things better? Now, it involves multiple domains to work on. It is on the psychological end, it is on the social end, it is on the economical end, it is on the uh, you know technology end, it is on the resource end. So you have to see things that way. Like what I'm like giving an
Indeed.
example, like Saudi Arabia right now. Saudi Arabia is right now working on a very ambitious project, which will enable them to do which will enable them to do trades in future when let's say their oil reserves will be depleted. Now, as of now, they don't require it. That is very much true. But they have to invest something for future, which will ensure that their citizens, their locality, their country can sustain. And for that, they need to do some investment, maybe risky investment. Ultimately, it's about ultimately everything that we do is a transaction. If you are buying something, you are doing a transaction. If you are going somewhere, there is some sort of transaction involved. We are moving on a cycle of transactions. So they also need to ensure that they do transactions so that they can stay relevant and sustain themselves. Same goes for India. Like right now, Indian government is trying their best to get the EVs on the roads, and the understanding is this, that that will enable less and less pollution happening in the cities and in the country in general, and the amount of carbon emission the country will do in future will get down. But
Yeah.
even though it might be as ambitious as possible, but that cannot pressurize, and that the government cannot push to stop using diesel or petrol vehicle, or put some sort of you cannot use, or you will have to pay some extra amount kind of laws they can't bring, because again you have to see the context scenarios. Like for instance, you mentioned yourself, there are places in our country wherein people are still facing issues with proper electricity, but there are big places like maybe us, for instance, at times when we are not are mindful of how we are using electricity and resources in general. That's there's that gap, and when anything has to be formulated, it has to be considered that it should not kind of impact any community or a group or an individual in a wrong manner, which for which they were not wrong in any way. They
Yeah.
were just trying to live, for instance.
Okay.
So, but yeah, the aspect of using the mindful resources is very much true, and that is the kind of thought that we should push on as well, and that is what I see as my perspective. But that's great. I kind of got to know what you feel as well about the same part. Cool. Moving on further forward, I would very much like to understand how do you see electronics as one of the pivotal, the electronic chips, rather the SoC silicon chip. How did it transform our society, and how do you see what kind of big impact it was able to make in our society?
You see, as of electronics, to give it more sense, there's this pattern in wars that have had happened in past. And if you give it more religious sense, um, though it is in sacred text, but still I take it as an inspiration. Mahabharata to everyone means something different. For me, Mahabharata means that for a civilization to excel, they should be clear with their thought process, and the individuals who were honest with their efforts and who were able to bring in an innovation were the key pivotal figures beyond that war and were not part of the bloodshed. To give it more sense, how Mahabharata ended was Dharamraj, along with Vishnu Bhagwan in form of dog, ascended to heaven over a staircase that was guided by God. What it meant was Dharamraj was the one who was able to derive lessons from it. To bring in analog in real world, World War One was the era where we transitioned from core mechanical industrial revolution to electromechanical revolution, wherein electrical machines came into picture and chemical enhancements. You see, with World War II, why America and Russia came in as powers was they were exploring on something that was at more atomic level.
Mhm.
So, though ICs as the application were there in market somewhere around 1970s, to be very frank, but their very concept that was underlying was of computation in one way or the other. That was pivoted into systems such as, if you have heard of it, Enigma, that was utilized by Germans and was very
Right.
well illustrated in that movie Imitation Game, starring Benedict Cumberbatch. And from our domain of aviation, there were aircrafts like P52. Then we've had the famous B-52 Stratos bomber and A-10 Warthog. Beneath of it were computational units that were able to do calculation on electron level. So that's where the foundations of using electrons as a means of calculation rather than mechanical hits and misses was fundamental. 1950s, as we all know, birth of transistor. So this very pivot was there, wherein the way additional isolated environment. I want to sound a bit technical. So there's this concept called vacuum tubes that were existing. To give it more sense, the tube lights that we have at our home are more or less vacuum tubes. Now even that are replaced. So these vacuum tubes, each tube represented possibility of two numbers. So in order to do a calculation of 256 into 256, you required 16 such tubes, 8 as an operator and 8 as operand. And again, more tubes in order to do multiple operations. So lighting such many tubes in array, even at your house, can increase your bills. So that was increasing bills on application. So then came in the transistor wherein we were able to control electrons at ease of by just a regulation in current supply. And when individuals like Gordon Moore and Fairchild were able to, William Shockley for that matter, were able to compress it down, uh, wherein all the operations that of mathematics can be abstracted in form of a circuit, and then all these individual circuits can be interfaced through a common unit into a single piece of just sand, was something that was fascinating for all of us. To give it more sense, Enigma, that was developed by Germans, decoding that required a whole batch of scientists at Great Britain to build a machine that was of size of a garage. And that much power was now in hands of individuals who were just carrying it that in their own risks. So I believe that would give you a perspective of how much this technology has impacted. And comparing that from 1970s to now, 1970s, a computer was able to perform fundamental operations. But now, if we create an array of such computers, then the size of sun would be equivalent to the processor that we have in the latest edition of iPhone 15. And going forward, it would double as well, as per a law called as Moore's law. I would like you to explore it. So yeah, electronics, if I want to explore it as a beauty of science, is something that has enabled our society altogether. And this very context might be sufficient enough to give how much significant role it had played in our society.
No, definitely. It has been a significant, and the aspect of right now we are discussing it live, real time, in a distance. It happened because we are able to utilize electronics in a way. So we have electronics which are specifically doing some calculations. We are having electronics and blend of some other physical hardwares which are able to, draw pictures for us. Again, it goes back to the concept of arrays in one way or another, but I guess that's an how you structurize and system puts things into picture. And many more things which if you go back in time when we were not having any computer and think back that we could have been at this stage, would be very much wild to us. It would be magic for us, perhaps. I don't know. That is one way to say it. Coming to you, because you mentioned and described Moore's law. Coming to Moore's law, right now some people believe that we have been able to place more and more transistor in an same surface area chip, and we have been able to make them compact in many ways. We are even right now, so we are right now placing transistors in 3D way. Like initially, like for instance,
Yeah.
if we have an chip, we are covering transistors on the surface area. But right now we are working on depth as well. So we are providing these transistors into the depth as well. So we are able to get more power out of it. And then there's an other aspect that we are making transistors smaller and smaller. Then there are some other effects which kind of can hamper the performance of transistors, because there are some atomic limitations which fascinatingly some people have been able to mitigate them as well, which is great to see. But the main question that I really here have is, some people believe that the Moore's law is coming to right now and sort of end. So the computational capability that can increase right now is coming to a plateau, and it might be possible that in some coming years, we might not be able to see as strong as computers every year as we are seeing it right now. What is your opinion on this? And yeah, let's start with this question. What is your opinion on this?
You see, speaking of Moore's law was utilized as a template altogether and is being utilized as a template. What I mean to say is, in order to increase the capability of our computation, we are not optimizing the architecture of that particular chip. We are just scaling it and we are just adding in our features.
Right.
So, to give it more sense, if we want our house to be like Mannat of Shah Rukh Khan, we
Mm-hmm.
are buying land equivalent of Mannat every year.
Mm-hmm.
So over due course of time, yes, on paper we have increased our capability of holding land from let's say 20 by 50 feet all the way till acres. But
Okay.
then have we optimized its interiors as what Mannat looks? That's the question that is still there. To give it more sense, by scaling the architecture, we were able to leverage our requirements of computation. But then we hadn't had innovated onto our internals of those architecture. To give you sense, we all have computers at our home.
Mm-hmm.
So we have either of x86, that is an 8086 based architecture, and AMD 64, that is an 64-bit architecture. Now,
Right.
I believe 8086 is quite familiar name that you've heard in your curriculars,
Definitely.
and it's quite old processors. It's one of the formative processors, and like if I want to give you a date where 8086 came into picture, it was in 1978. So from 1978, aren't we able to build something that is equivalent to 8086 and beyond? That's one question. And to give you more perspective, atomic sizes would come into picture after a while with this scaling property. You see, currently we stand at 3 nanometer. We are
Right.
able to optimize the architecture in third dimension. The latest invention happened to be GAFET, Gate All Around Field Effect Transistor.
Right.
And what this nanometer means, to give a more perspective to audience, there are three terminals into a transistor. They are known as source, drain, and gate. So it's the distance between drain and gate, the two extremities of terminals of a transistor. So it's the distance between them. After a period of time, if you look at fundamental levels, what it is one atom or the other. And I don't want to go into quantum mechanics of it. We all have read Bohr's atomic model. It's more circular in nature. And there's this mathematical equation that gives us the radius of any atom. So radius of fundamental hydrogen atom happens to be 0.529 angstrom. That is 0.05 nanometer. So if we scale by the speed at which we are scaling right now, this scaling would make us stop at I would say 50 or 25 years going forward. And that too, I'm talking in terms of hydrogen atom. What we
Right.
utilize in our semiconductors is silicon multiplied
Right.
by 14. So yes, the challenge is there in front of us in next 10 years. So what we can do is optimize architectures, and this has given us benefits. You see, in terms of laptop technology, Apple did really wonders by introducing this architecture known as ARM.
Risk
So
architecture.
they've utilized this architecture known as ARM, Advanced Risk Machine. So as of implementation, it was different from 8086 based x86 and AMD 64. And what it gave was enormous power of 10 to 12 hours in real time in palm of our hands and made our laptops more portable. So by experimenting onto the semiconductors architecture, if they are able to get it, and to give you a comparison, ARM and x86 don't vary much in terms of their implementation. Only their fundamental way of operating instruction is changed. Not even their digital electronic aspect. One is in condensed instruction set code architecture, wherein instructions are condensed over due cost of delay of their execution. And one is reduced instruction set architecture, wherein number of instructions are reduced, delay can be managed. So
Right.
by just implementation methods, we are able to achieve such differences. So yeah, going forward, when we will hit the plateau, we'll have to optimize on architecture level. Again, to give it context, when we have limitation of property, how we make it look more luxurious by investing in the internals, by decorating the interiors. To point it on a lighter note, you see videos on Instagram wherein people install mirrors at their very small homes in Hong Kong and Mumbai, for that matter, to make them look big. So that's how we leverage the enhancements by internally tweaking in systems and getting the results after that petal plateau.
Right. That's true and fascinating as well. And now, since you brought this point, I kind of wanted to discuss this specific thing about architectures in general. Like right now, what we are discussing is like in a very simplistic way, if I have to say, which will still be complex, but let's we still try.
Yeah.
Intel, AMD, and Nvidia right now are using CISC based architecture, which is
Yep.
what has been prevalent in market from the starting of computers. What Apple is right now trying to do is use a risk-based architecture, which you mentioned. And the interesting part is risk-based architectures are as old as CISC-based architecture. So it's not that risk-based architecture is a new, architecture which came into market. It was there, but no one really took it very seriously. There were some people, I guess, from Britain, I'm not sure, but who initially
Mhm.
worked on it. Sometimes around the time Apple saw the potential in it, and but at that time, I guess risk-based architecture was kind of supposed that they are not very, they are not strong enough in terms of handling strong computations. That was a kind of perception, if I'm right on that part. Then when Apple saw its potential, the amount of energy it consumes, um, they started investing in it. Even before Apple smartphones, which we have, like ARM based, Snapdragon, AMD, they have been using this based architectures, and that is why we were able to use smartphones for a much longer period of time as compared to normal laptops what we have right now. The only aspect that changed here is Apple introduced the risk based architectures with M1 chip on the mainstream, and it really changed the way. What do you think? Why risk-based architecture was not really recognized at the time? And yeah, what do you think? Why it happened? And now, what do you think? How risk-based architectures will change the coming future of computation?
You see, it's not more of recognition or importance that play into come into picture. It's more of how it was marketed. When Valley of Boom was there, wherein say, Silicon Valley was growing. So whole world believe, okay, what happens in Silicon Valley? would happen on computing. So in order transaction to happen, there must be mediators. These mediators are known as preneurs, entrepreneurs for that matter, who
Mm-hmm.
created preneur out of it. So at the time, individuals like Gordon Murray, along with William Shockley, started this company called Intel, and they were able to prove their potential to institutes known as IBM, and going forward to various other companies. And there came in individuals who made their circuits work, like Steve Jobs and Bill Gates for that matter. And to give it more sense, Steve Jobs was the one to utilize it. This is one story I want to digress a bit from architectures all the way back to why this need and want was created. The Apple, which we are appreciating right now, experimented with ARM architecture, was the very first company to bring microprocessors to the commercial market. You see, IBM marketed those bulky machines. Apple wanted their Apple One and Apple Two to be small. So what Steve Wozniak, one of the founding members of Apple and the actual builder of Apple, what he did is he was looking into this magazine known as Electronica. I'm not able to, not electronics, this is something computers related. Popular
Okay.
Mechanics, sorry. Yes, Popular Mechanics. That featured an article of Intel's 8085, 8086 at that time. And there was this homebrew computing club in the Silicon Valley that was there, wherein individuals came in and showed their architecture. That's where Mr. Wozniak was able to understand that, okay, the system that we are building of these many circuits, of individual discrete digital circuits, is now compressed into a single form factor that has 28 to 40 pins. And I can interface that with using only three more additional circuits rather than my previous circuit of 100 components. That's how they were able to realize the very utility of x86. And you see, individuals who are there in market, they don't have time to experiment a lot once their product is there in market. Then it becomes a unique standard operating procedure. So once they started earning capital out of it, they cannot experiment on daily basis. So they had to move ahead with the trend. What was required, however, was individuals who can work in as entrepreneurs in the region of United Kingdom and European Union, who could have brought this concept of ARM to commercial applications and then would have leveraged its capability. And now, to give you more sense, the first company, one of the first companies to leverage that was a European company known as Nokia. We might
Right.
forget it, who
Yeah.
utilize ARM architectures into
Right.
their Symbian based systems. And that's
Okay.
where the world was able to analyze the fundamentals of a system that, okay, um, there exists an architecture beyond x86 that is providing us computational capabilities over palm of our hand. And then came in big companies like BlackBerry, Samsung, and the stories in front of us. So you see, up until there is no a preneur, there would be a link between demand and supply. And when the preneurs are not there, either sides would be screaming of scarcity. So that's
Right.
how I would like to put it forward.
So you require some people who can take risks and build something which was not supposed
Indeed,
to. Got it.
indeed.
So so there are a few more things, interesting things happening in this specific sector as well, and I would like to know what is your opinion on this. Right now, there are works happening on, like you mentioned, and entrepreneurs are doing these works. There are works happening on making analog computer a reality. Then there is
Yeah,
quantum computer which people are trying to work on, which
yeah,
something will be one of the big thing because of the way how quantum computers work and the kind of computational ability they can bring in. So and few other experiments are happening as well, which I can't recall right now. But there are these innovation or that attempts are happening. Like there are people who are there is this. there's just, I guess, a few months back there was this research published in South Korea, I believe, wherein the researchers said that it probably is possible for us to create superconductors on a normal temperature, which again brings back to feasibility of quantum computing, more realistic thing, but which never really happened. There were some other applications as well, but the point is this: people are trying to push quantum computing, analog computers into picture as well. How do you see these systems and electronic based system that we have right now, which is a digital system, competing with each other, competing with them, and what do you see? How will the future of computation will look like?
Mm. You see, these systems have existed in the past. If you recall, in school, we were taught these three type of computers: microcomputers, mainframe computers, and supercomputers.
Right.
Based on application, the markets have existed. It's
Yes, sir.
just that in microcomputer segment, because of our demand, we are further crossing the boundary of mainframe and microcomputer. But yes, for systems that involve calculations to be the very fundamental of requirement in terms of weather calculations, you see, we utilize systems for orbital mechanics of satellite launch and trajectories. Therein, we don't want a fancy graphical user interface. We don't want animations. We want
Okay.
that system to do complex calculus over due course of time at lowest latencies. In factories, we don't want system that can do complex calculations, rather that can prompt us in microseconds of any fault that happens and take mitigative actions. So it varies based upon the application at the moment. So all of these architectures are being explored, or these implementations of computers, based on their very relevance of domain. Quantum computers for commercial market doesn't make sense at the moment. However, it is a boon for complex calculations. The reason being, currently we operate on this concept of binary numbers.
Right.
So binary numbers are more, if I give it context, represented in 0 and 1. In terms of coin flipping, head may be 0 and tail may be 1. Quantum computers are operating on phase of any electron. There's this magnetic quantum number that influences the very operation. In terms of coin, when we toss a coin, so what we are observing is not head or tail. We are now observing how much of it is head and how much of it is tail. And based upon our ability to capture the position at that very moment, we are able to get resolutions of bits known as qubits, quantum bits. So that
Right.
is giving us number of, let's say, if we have a qubit that has capacity of 4. So our single bit was able to represent 0 and 1. Now we have capacity from 0 to 16 to be represented onto that very fundamental. In my macrocosm, even a binary number is able to do teraflops of calculation. So such qubits can extrapolate it to octoflops of calculation, and that is required for systems like weather prediction, for satellite maintenance, for orbital mechanics, as I've mentioned, rocket
Right.
dynamics, to name a few. As of our commercial application, and this is one thing that I would like to optimize onto your suggestions. NVIDIA doesn't utilize x86 architecture. They are in a different game altogether. They are working on parallel computing systems. So again, that are more of a graphic cards. What they do is they perform fundamental calculations of addition and subtraction that is done over an array of units. So their
Mhm.
architecture are simple in of implementation, but they are cascaded in multiple arrays.
Okay.
What x86 is doing complex set of calculations over a given span of time. To make it more sense, the video that we are seeing right now, it is more or less doing fundamental operations of addition and subtraction of colors. However, what makes this video transmit over a particular channel of media, internet, that is transmitted over Ethernet or Wi-Fi, that involves encoding, that involves complex calculations. That's where processors come into play. So graphical processors were more of from NVIDIA, and central processors were more of from companies like Qualcomm and Intel. So
Okay.
application specific architectures are being explored. So speaking of analog computers also, they have a very niche domain that would be catered by their implementation. So we as consumers, it's good for us to have a literary knowledge of them. But yes, they won't be that much beneficial for us as an end user in commercial electronics. So that's how I would like
So,
to put it forward.
what do you think? Where will analog computers be used in future? You
Uh,
mentioned
you see,
quantum.
yeah, analog computers are required for very tasks wherein quality or fidelity is required. You've seen this movie of Christopher Nolan, this called Oppenheimer.
Right.
Yeah.
Yeah.
So there was this very buzz around that 70 millimeter film that they were using. Now the question should be, we live in the digital world. We've got encodings of 180A, that is 1920. 8K resolutions are encoded onto our displays.
Right.
And despite of that, he's using an analog way of recording uh, media onto a celluloid film of 70 millimeter and projecting it through a semi-analog means onto a screen. So why he is doing that? Because analog systems provide us higher fidelity. You see, digital systems compromise on quality in form of sampling the data. What I mean to say is, assume data to be a river. What digital systems are doing, they are like a spin wheel that is leveraging water from that river on a regular interval. This interval is known as sampling rate. So if we try to collect that water and flow it in another canal, so that canal would have the water that is flowing in that river, but it won't have the same amount of minerals, the same amount of flow, and same amount of audacity of that water that is being flown. That's how video and audio systems work. And even for other systems that are more, I would say, varied in terms of their representation, these systems, as of their application, require higher fidelity. And when higher fidelity comes in picture, analog systems are easier to implement. To dig deep a bit more technically, and audience, they want to relate, they can also relate to this concept of filters. So there are analog filters and there are digital filters. So what filters do is they alter the pitch of our sound or video. So there are low pass filters that filter out the lower frequencies of sound, and higher pass filter that filter out higher frequencies of sound. Their analogs implementation requires only a resistor and a capacitor, two fundamental components that are easily available in market. However, their digital implementation requires lot of calculations that are exponential in nature, that involves calculus, and that is represented on multiple transistors onto our uh, computing unit. Again, uh, analog systems were better. They utilize less power, but still, our application was centered around that single monolith. So we utilize digital systems. But then for individuals who need higher fidelity, they can utilize analog systems. Though might be bulky, though might draw a lot of power in larger sense. But yes, quality is being delivered, and that's why analog systems, analog computers altogether are being implemented. So that we need not to create a whole canal out of it, do our computation, and put the water back into the river. And
Mhm.
on a lighter note, there's this video that was trending ahead. This process, what it can cause problem, or what has been causing problem lately is uh, this compromises a lot on quality and distorts our output. and even sometimes can overflow. There's this one video I believe you might have also seen, a Florida beach wherein an individual dig a canal between the two ends of ocean. So that
Okay.
canal went haywire and a whole island was created due to the flow of canal. And that's what would happen or is happening. Our computational capabilities have exceeded to such a point that if we don't tune in, either we tune in such an extent that we are able to critically balance the fidelity and digital capability of computation, or you'll lose out on quality of the output. And that's why analog computers are required.
Right, got it. And I think because of the fidelity part, and that is one of the issues with, let's say, if you want to work with machine learning models as well, because they
Yeah.
work on probabilities in a way. Um, Using analog computers might make more sense as compared to digital computers because they can easily, store that information and train the models as per what is required, and less computational power will be required to do that as well. So probably analog computers can be used in that field as well, but that is yet to be seen. And this really brings me an interesting aspect of what is happening right now in architecture, and I would like to know your opinion on this. Initially, when we had computers, we just simply had an CPU in our systems, and it was supposed to do everything in our system. Then came a time when we had CPU in a system and a GPU. CPU has a specific task to perform, mostly the normal tasks that we do, and GPU focuses on tasks which requires a lot of parallel computing or graphic rendering again, which is a part of parallel computing and all. So we had this. Right now we are shifting ourselves. Now we have CPU, we have GPU, and we have some processors in our system, even in our phone itself, processor optimized for AI as well. So those processors are specifically meant to be used to perform some machine learning calculations or AI based predictions. So they are utilized. So this trend is going on right now, and to add on further to it, we right now also have a DPU. Do you know about DPU? Have you heard about DPU?
Can you de-elaborate it?
Data
Because
processing
as a
unit.
yeah, I've heard about it.
Yeah. So now, right now, even people are working on DPU as well. So, like, based on the specific requirement and functionality we are having, we are kind of enhancing and segregating the work and uh, type of computational units for ourselves. What is your opinion on this, and how do you see this concept overall in general?
You see, it again comes in retrospect of our need and requirements. So, over due course of time on commercial applications, we required more of a graphical content. So, our native complex calculation performing CPU was not able to handle such much jargon of tasks. So, a simple task performing super scaled implementation known as GPU came into picture. Now we need tasks that again do multiple amounts of processing. But yes, once the processing is done and we've received the desired output, we can freeze that. That was not in the case of a graphical processing unit. Then came in these units known as tensor processing unit. So
Yeah.
wherein we've added a dimension and that dimension can be freezed in form of architectures of systems known as neural networks or AI-based equations altogether. Going forward, the data that we are currently storing in our local memories that can be again freezed or as per our requirements would then serve the purpose of data processing unit. So yes, this abstraction of components would happen and is feasible, can be done. However, what I want from these implementations is a single monolith based approach. If you've seen newer semiconductor implementations of products, they have integrated all these implementations into a single unit. But again, from technical standpoint, these single units are a good niche. But coming back to the nature standpoint, I need components that can be replaced in real time
Right.
because if I integrate them together into a single monolith, I can optimize my power. I am able to reduce my delays. I'm getting results faster. But yes, if either of these components fail in real time, my whole circuit is to be replaced.
True.
That would cost me at individual level as well, and at company level might cost the company as well. However, if these units are separated, these units have modularity in them, then at least if your DPU fails, we only have to deal with DPU. We need not to replace the whole motherboard altogether. So that's a kind of a dichotomous dilemma that I have right now.
Got it. It's understandable, and I guess in my opinion, I guess the answer is, um, let's just talk about specific case study requirement. Like there are places where you can't expect a delay, and having non-monolithic modular approach somehow kind of impacts the performance of system. But if you have monolithic, you can get more out of it. But again,
Agreed.
there's a catch towards it as well. So I guess ultimately it will, the question will come out is, where do you require it and why do you require it. Based on this, you can make the right calls of what kind of architecture you really want to implement, coming in the time. Right. So there's this new thing which is happening. Not a new thing, rather it has been into industry and people have been working on it. But in my understanding, this specific field of IoT and robotics in general is catching a pace right now. And I think with the advancement of AI, it will even go more, standard, and it will go into mainstream even more than what it is right now. What, how do you see it in near future, and where do you see right now the progress IoT enabled system has made from the start till this time?
Well, rightly said by you, IoT as a system is quite mature. To give you further more context, first IoT system that we as civilization had was in Sputnik 1,
Right.
where the thing was Sputnik 1 and Russians were observing fundamental data onto it.
True.
And if I want to sound a bit more corporate, after that, a perfect IoT system that made sense in terms of implementation was an electronic flight control computer known as Lunar Landing Research Vehicle that was
Okay.
implemented by NASA's Jet Propulsion Laboratory at Dryden Flight Research Center that was there to provide maneuver to the Apollo lunar module that was utilized by Neil Armstrong and Buzz Aldrin on Apollo 11 mission. So this unit had systems that were communicating with each other, and then in return they were sending their observations back to Pasadena and Houston altogether. So that was the very first fundamental of IoT as a system. What we see right now as a rise is because of affordability.
True.
And why it is affordable more than before is the very fact of scaling of architectures. Earlier, these IoT-based systems required processors that were big in size. 8085 and 86, though were small, but comparatively were bigger in terms of implementation.
And they were not
After
strong
processor,
together. Yeah.
yes, to give you more sense, 8085 required two more components in addition to it to perform perfectly. There was this component known as random access memory. There was this component known as read-only memory that used to store the data that was being indexed or over which the operations are to be performed. In addition to that was an interrupt controller that was there to manage the human inputs to the processor. And there was peripheral controllers because we were moving to commercial applications. So each peripheral had a different way of communicating with the processor. Then came in an implementation that incorporated all these three components into a single unit known as microcontroller. as of my good known knowledge, the most like legacy legend was 8051.
Mm-hmm.
And how it changed the whole scenario altogether was it was giving the computational powers of an Apple one into the size of our hand. And this was the legend behind this video game console known as Game Boy, if you have heard of it, wherein four batteries were only required to operate a game, and you were able to bounce your Mario onto a screen.
Okay.
So, with this much
You
abstraction,
mean that cubicle stuff we have game players?
yes,
Okay.
yes. So, but still, at that time, that was expensive. Those who were into a really good aristocracy were able to afford that Game Boy, and that was not able to do real-time operations at that very extent. With now, again, it is a self-contradicting point. With scaling of architectures onto the same size by increasing the number of transistors, we were able to increase the computational capability of that microcontroller. And now what we have is microcontrollers have multiple peripherals, multiple interrupt handling capabilities, and real-time operations embedded into a single unit, and that can be reproduced in larger sizes. So that provides affordability. So why it is affordable is in 1980s or 90s, each processor has a silicon wafer inside it. How this wafer was mined was by cutting, by first creating laser-based. I want to give you a bit more context because it's a bit technical, and the audience won't be directly able to relate it. Um, you see, this wafer is more or less like a drawing that you're doing on a canvas. So if you have a broader brush, you can create that whole house drawing with the two mountains onto a whole canvas. Now, if I give you with a smaller brush and ask you to do two drawings, you can do that. And the more I am able to reduce the size of the pointedness of my brush, I can cascade these drawings into various elements.
The
That's
price
how overdue. Yes,
is good.
yes. So over due course of time, when in 1990s we were able to cut two or three ICs out of a single wafer of 10 inch or 14 inch, now we are able to cut around 100 wafers out of that 10 or 14 inch. So the unit cost of that wafer is reduced because from a wafer that used to cost around $2,000, we are able to initially mine only two units so that each unit costed at cost price of $1,000. Now that wafer with 100 unit is costing around a cost price of $20. I'm just giving a more generalized calculation. It is way lesser in terms of their costings or even more based on application. So as we were able to optimize our transistor efficiency, packing efficiency, and cutting efficiency, we got multiple waferlets that in turn gave us affordable microcontrollers, and that in turn created this very that was also reciprocated in the domain of wireless communication as well. Wireless communication again requires a semiconductor implementation. So what we were able to do, the two units, one a computing unit, one a transmitting unit, is now embedded into a single chip. That created the picture of IoT. So wherein for lunar landing research vehicle, we required a huge big horn antenna to communicate back and forth with the Earth. Now that antenna is microstrip sized, embedded onto a single monolith at palm size of a nail, and that is giving us the capability of computing and transmitting the data over a given channel. And that's how IoT as a domain is booming. Speaking of robotics, I would partly disagree. We are optimizing on robotic capabilities that are more of mechanical in nature. The
Mm-hmm.
computing capability only saw innovation in three domains. There's this domain known as simultaneous localization and mapping, or SLAM. that provides us a 3D map of a given terrain. That's where we are seeing innovation. Second is of again somehow related to IoT is of predicative maintenance, wherein the system itself is able to resonate with the client that I have problem in given segment of my operation. And third is this feature that is yet to come in market but is slowly picking up pace, known as digital twin, wherein impacts that are happening onto real system are reciprocated onto an abstracted system at a remote location. Uh, to put it more generalized, an operator in Kyoto or Fukushima can operate an individual in Los Angeles via retrograding controls from Fukushima, and those are reciprocated on robotic equipment that are there in Los Angeles, operating onto a cesarean operation. These are the only three domain in terms of electronic implementation where we are seeing innovation. Other than that, all are more or less mechanical or aerodynamic in nature.
Got it. But don't you think robotics is a kind of hub of everything? Like you have a software, you have a hardware, you made them interact and things happen. Like my way of seeing thing is like one of the best example that I can, if I have to give of robotics, which I don't know if how much you will agree or not, is if I have to give a best example of robotics right now is self-driving cars. So they have their own hardwares, they have the softwares, they have actuators, they perceive the environment around them, they react as per what have been commanded to them and what is in front of them. So if they have to take a turn, they take a turn. If they have to go reverse, they go reverse. There is this localization fact which is enabling them from moving from one part of city to a different part of city. That's just one example. Big companies like Amazon and all have been using robotics from a long time for robots from a long time, or maybe from years, if to be more accurate, because I don't exactly remember the years. They have been using them to shift things from one place to another because in their warehouses, and the B2B segments have been using it on a more frequent basis. Then there are some other examples as well. But the biggest thing that I really find very myself interesting and something that I really am looking forward to is um given the accessibility that we have right now with work for with working on like Arduino or Raspberry Pi and all, wherein you are able to again robotics system and hardware and software interaction happens and something happens. You are able to interact with the given hardware that you have. You use some peripheral devices, you upload a software and it just works. People with these things on their own backyard are able to make prototypes of SpaceX rockets, testing them out, and there are some examples. They are able to make an affordable, just in prototype again, self-driving vehicles for their own, and various small innovations on their end. And some small innovations, because of the utility, are coming into market right now as well. So it's kind of uh, I don't know what is the right word, but decentralization of these resources onto people, and when they get you know their hands on it, now it is something which is like catching a pace. Like so one thing that I'll say is the software is very, very successful in industry right now is because everyone can use and work on it. Like I just require a system. If I have a system, I just require some courses and I can work as much as I require. Same is not true for electronics, neither it is true for civil engineering or mechanical. You require hardwares which cost you significantly to work on those segments. In our college time we were able to work on robotics or all these embedded system is because the affordability was there. If there was no affordability, some of the innovation that we thought of, maybe if we have not implemented it, was not supposed to happen. So what I mean to say is, maybe on a deep tech right now there are some segments of robotics which are not really touched yet, or there is no real innovations. But in terms of um, productive ideas, or maybe different thinking ideas which can come, they are happening even in our smartphones as well in certain ways. But that is just my understanding, and from the angle I see, robotics is sort of prospering in ways, and probably it is quite possible, given the way right now the industry is operating, that more and more things can come into or systems can come into picture. But again, that might not be true as well, because again it depends on various situations. It depends on the economical factor, it depends on the social factor, it depends on the market requirement as well. So certain innovations might not be really welcomed by market as well, which has been true in terms of robotics, especially in India, because people maybe are not yet ready for the robotic innovations, which can maybe change certain aspects of how they operate in life. But having said that, there are some other works that are also going on, like some institutional colleges and universities are working on creating humanoid robots. Tesla is working on their prototype of humanoid robot. There are some startups who are working on some sort of robots who can work, or just do the human based things in a way. Then there are some startups like, there is one startup that I came across, and there are many others, wherein they have this two-dimensional, three-dimensional rather, movie. Like, what I mean to say is, they have a system which can cook a food for you. You just tell what kind
Great.
of food you need to cook. Let us say that they have some sort of hands, and it can just slice things up, cut vegetables, cook the things the way a human does, but in more efficient and more repetitive manner, because systems don't really, or computers, robots in general, don't really exhaust as compared to what humans do. So
Great.
there are some pushes happening on that side as well. Again, maybe not from the core deep side of it, but something that I kind of believe on.
Yeah.
Um, yeah, you wanted to say something on this?
Again, to give it more perspective, you see, robotics is amalgamation of complete engineering as a domain.
That's true.
But having said that, it is also true that when we look at innovation altogether in engineering, I am not fascinated by various abstractions of it as an implementation. What I am looking forward, or rather, what an individual who is there investing in this platform for foresight of future is looking for is where innovation is happening. You see, with Tesla, it was more or less like an SLAM enabled automatic ground vehicle that gives human capability to steer it, correct?
Right.
In similar fashion, what Amazon and various e-commerce companies are utilizing at their warehouse is an autonomous ground rover, which again utilizes fundamentals of path following and maze solving. So, as a robot abstraction, it is a good implementation. However, when I look it from a technology standpoint, the very three fundamentals is where we can easily categorize and study them more precisely to bring in innovation. So, in terms of conformative robotics, as you were talking, those three 2D and 3D formations of robot,
Right.
conformations is more of a mechanical integration, and that involves collaborative or I would say predicative maintenance in one way or the other, wherein one robot is echoing its signal to the next segment, they are predicating each other, and then that's how they are collaborating. So they come under the subset of predicative maintenance, because again maintenance, when maintenance happens, when there is an operation that involves multiple segments of interaction. So all swarm robots that we are seeing right now, they one on the other way happen to be in the category of predicative maintenance. Speaking of affordability and innovation, It again is catalyzed by the factor of ease of access and unit costs being reduced. Speaking of electronics and computers, if I want to bring in a perspective to it, a computer is enabled by electronic systems. So why a computer is able to give you the same cost is because someone has invested hundreds of components at his experimental stage to freeze this computer as a requirement.
True.
Prior to that electronic implementation, someone has experimented 1,000 times onto materials to decide what is conductor and what is insulator. And prior to that, going back propagating in the chain, someone was as a supplier supplying those materials to that individual that were chemically composed, and how these chemical compositions happened were through machine operations that were performed onto raw material. That in turn was possible because someone was able to understand the fundamentals of construction and was able to realize mass scale architectures into buildings that came into as factories. So, as we move ahead in this chain of abstraction, we'll increase the affordability and accessibility, and that we are seeing right now. Generative AI, when I was studying as individual, was quite a niche thing, wherein you had to download the code from this platform of open source information known as GitHub. You have to train it onto your local computing units for 2 3 days 4 days. Once you are done with that, then that system was capable enough to do operations. Now, since someone has figured out, okay, this is the best optimal implementation or trained version of that unit, that individual Sam Altman of OpenAI provided it as a service.
Right.
So going forward, again, someone would optimize onto it, and there would be an ease of access. So what I infer out of it is, as technologies advance, if that technology is able to bring in affordability and accessibility, that works, and that has been the staple. So that's my take onto it. However, I again would now like to freeze it on the note: do we need any further enhancement? Like, on a serious note, do we need ChatGPT in first place?
Maybe at this stage of time we don't require, like, it's an interesting question, but it is an hard question to answer. Like, right now we don't require chat gpt, but at a certain moment of time we would not require computers, but now since we had computers we were able to figure out how can we utilize it. It is true for ChatGPT as well. Do we require ChatGPT right now? We don't require perhaps ChatGPT right now, not an urgent basis or something which is kind of making us stopping somewhere. But the fact that right now we have a ChatGPT which is able to make our lives easy in ways that we haven't imagined right now. We are using it. Another example is Netflix. We don't require Netflix. We can maybe just simply see the television that we had, or we just do the things that we want to do. But the fact that right now we have Netflix, we have the ability to look into content, uh, whatever we want, and at an hand of at a click or hand or a click from a remote button from a remote, for instance, we are able to see the contents. We don't require it because now since we have it, we are utilizing it. So it's an hard question to answer. I guess right now we don't require it, but in future we might feel it is required, similar to what we have right now with computers.
Yeah. Um, I would like to know your opinion onto it, as in it again comes onto the question of need and want. And
Mhm.
speaking of need and want, what I have a perspective onto it. I don't believe it because I haven't had validated it at the moment. But as we are moving ahead with technology, you see, in order to balance out the entropy of universe has a very beautiful way of compensating everything. So
True.
if we are getting win of affordability and accessibility, universes and narrowing our perception of information. So earlier, if I want to give you context, the civil engineers who used to read books, they used to perceive information for over the period of years, and that's evident in Ajanta Ellora caves in India.
Hmm.
It's really one marvelous that three or four generations of individuals were able to reciprocate the knowledge of engineering. How was that possible? Because they've read content or they've recited the content.
Right.
Going forward, when content was mass published in form of written media that can be reproduced easily, our retention rate was limited to the amount of frequency of distribution of information. So rather than now we learning upon the lessons learned, we were absorbing information that was provided by authors. With current digital media, we have everything in form of 1 to 2 hour movies or half an hour on demand content. So our
Right.
perception time is limited to half an hour to 2 hour. Like we happen to be from the generation that has seen movies in cinema, and now we are seeing content on these on demand platforms. So our perception time is of order of few hours or a day. Going forward, as the technology is abstracted to implementation like chat gpt and AI enhanced content delivery, we have microform entertainment in YouTube shorts or Instagram reels, to give a context. And we see that in younger generation, though they are technically more capable than us and they know far more piece of technology than us, but they don't have the very capability that made us humans apart from primate as a species. And going forward, their thinking capability would be limited to 15 seconds. After 15 seconds, they either require something new, some masala, or they won't be able to retain what the lesson was learned over the due course of 15 seconds. So yeah, that's where, and if the chat GPT comes into picture, then we are not even giving that much of effort. Okay, chat GPT, I want to draft an resignation letter to my organization. What would happen? Chat GPT is drafting resignation. Chat GPT is knowing, okay, this guy is leaving the company. I am not reciprocating the feelings. However, you do one thing. This is one task that you can do. I won't ask you to do in terms of resignation letter because we won't get that much opportunity.
Right.
But as a gratitude letter or as a birthday wish of your co-teammate or colleague, you provide him three media. One, wherein you go in and address him in person. Second, you write a letter to him. Third, you provide an email to him. Fourth, you ask chat gpt or google like fourth you google phrases of birthday wishes, and fifth you ask chat gpt to write birthday wish, and do it on six individuals and seek for their responses. You'll see that the very fabric of attachment is more with your personal interaction. And as we are abstracting technology with it, universe is taking back the energy of happiness from us, energy of connect from us. So if we have provided positive entropy on accessibility and affordability, our experience, our cadence of experience is reducing. So that's how I would like to put it forward, and that's where the very need of freezing our requirement come into picture. That it's high time that we freeze our requirement. Or going forward, there's this one famous image. Now machine is learning and human is machining.
Okay. Got it. It's an interesting point that you mentioned, and I'll say I had a thought about it, and I'm pretty much sure there are people who have been thinking over it as well. I'm pretty much sure even industry leaders, entrepreneurs like Elon Musk, Sam Altman, other people are also thinking about it. They had some of their own perceptions on this. Um, I'm very much looking into what will happen in future, which I can't say Honestly speaking, I cannot say this will happen, that will happen, because I certainly don't know. There are two ways of seeing it. It's one is an optimistic ways, other is, um, an pessimistic way, when you say, we as a human society will forget what it means to be human, perhaps. Um, what I still believe is, it depends on how we use the technology. And I don't know what will happen in future. It's just my understanding right now. Um, Technology is just an enabler for you to do some specific thing in a right manner, right?
Indeed.
The moment you start, and I believe it in certain ways, the moment you start relying on it too much more than what you require to, you are not doing things in the right way. People are realizing it, like, and people are realizing it. How I'm trying to say it is as, when Facebook and social media in general came, people were so much into it. Even I was so much into it. I remember in my tens,
Indeed.
I used to go at home, and whatever way I used to get maybe a phone or a system, I just used to go into log into my Facebook, find out where if my friends are there, connect to them, interact with them. Fast forward to this stage, I am not even using Facebook, because after a moment of, addiction to it, I realized, where does it really lie in my where does it really lie in my life, and how much prioritization do I need to put into on Facebook. So what I mean to say is, as robots, course correct themselves when they make mistakes, I see in an optimistic way that humans will also course correct, in a way to understand how much of technology that they really need to use. Like, the best example that I can give, which is not true in a way, is Dune, for instance. I am not sure if you have seen the story of Dune, not just a movie.
Indeed.
Uh,
I've read
it-
both.
yeah, the way it goes is, humans were too much into technology and all. Humans were too much into technology, so much so that they once kind of destroyed their own civilization. But after a moment of time, they realized that maybe too much dependency of technology, robots, AI might not really work for us. Find the right balance, which is really which is really relevant to us. Then they are right now at a stage when we are seeing this movie, the plot which is happening right now. So again, I think we will make mistake, but I think we will course correct ourselves. Definitely, if that mistake is very big, when we won't even get a chance to course correct ourselves, that will be an, well, um, happy to say we lived our life the best we could. So you can,
Indeed.
call off the chapters that way. But if we got a chance, I think we'll course correct, because ultimately the survival matters, and that's what is embedded in ourselves, in a way. So very much looking forward to see how it really turns out. But let's
Indeed.
see.
Yeah,
Yeah.
so
So,
coming back to that book that I was mentioning, and that also addresses the very thought process that you are thinking. It might even help the audience as well. There's this book known as The Ministry for the Future by Kim Stanley Robinson. So it's quite an underrated book. So it opens up in the context of not so dystopian future, wherein climate change is one of the factors that is driving executives and politicians around the globe to come up with solutions to cope up the issues. And it ends on a very good note, though quite bleak in its conclusion, but still, if you're able to bring in lessons from it, you will have points of optimization at current level where we can um, deviate from what is being projected from that very book. And speaking of optimal future, we do have the best thing that we have as a species is hope, and this is what drives us forward.
right, that's
And what we can do as individuals is on this very small span of 100 years, we can reciprocate um, something for the society altogether, so that at the end of the day, um, we are social animals. So the herd along with whom we have traveled this journey all the way till end, At least that herd is satisfied. Okay, we've been with individuals who were there with us, and this is very famous thing from this movie called Avengers: Age of Ultron, wherein the two robots are interacting with each other, and Ultron says, at the end of the day, humans would die. I don't remember exact phrase. So why are
Yeah.
you trying to protect them? So this evolved version of robot says, despite of the fact that they'll die, it's their
Jarvis says, yeah.
yes, it's their hope and the way they are living with each other is what matters. And in the longer course of time, that is more beautiful than being alive for infinity. So you see, there are bigger problems. Being an astrophysics fan, 47 million years from now, our sun would happen to create a coronal discharge that would evaporate every material on Earth. 23 million years from now, Andromeda galaxy would start approaching towards Milky Way galaxy, creating gravitational disturbances.
True.
10 million years from now, uh, asteroid belt would enter into a spiral orbit, disturbing onto our gravitational fields. 300 years from now, there would be a magnetic surcharge of sun that would directly happen onto the Earth's surface that can even destroy our ozone layer. But yes, over the due course of macrocosms, there are microcosms like 2 hours and 30 minutes back. We were excited to have this conversation right now.
Right.
And 5 hours back, I was excited. I was cherished by the weather of the city where I live and seeing people celebrate Ganpati Ji's celebration. So you see, in larger scale of events, these are milestones that keep us sank and provide us a goal that, despite of the darkness in this space, it's on us how we can create light out of it. And these small moments that we enjoy on my minuscule level at each and every frame of time, these moments help us around when our own light tries to diminish. These are the driving entropy that ignites the hope of light in us.